Our next few videos are going to focus on igneous rocks, those that are forming from either lava or magma that are cooling down and solidifying into a new rock. So igneous rocks are forming from either lava or magma, and here there's actually an important difference between those two words. Both of them are some kind of molten or melted rock material, but the main difference is where they're located. Magma is found inside of the Earth, whereas lava is on the surface of our planet. So magma generally forms inside of the planet in our mantle, where rocks are melted due to that really high heat coming from the core. But when we have a liquid under pressure and we're heating it up, it likes to rise to the surface and escape from all of that heat and pressure. So we have this hot magma rising from our mantle towards our crust. And sometimes it can escape and make its way to the surface, at which point we're going to call that melted material lava. And we're going to see that igneous rocks either form from lava on the surface of our planet or from magma inside the planet. So depending on where this molten material is solidifying, we're either going to call it an extrusive or an intrusive igneous rock. So starting off with extrusive, this is where that molten material has exited the Earth. And I remember this because extrusive means exit. So with this, we have that magma escaping the Earth and solidifying as lava on the surface. So we see this a lot with volcanic eruptions. But unfortunately, if you like to watch a lot of really bad science movies like I do, most volcanic eruptions are nothing like what we see in the movies. They're not explosive and violent. Instead, they're just gently releasing lava at the surface, kind of like what we see here in this image. And these kind of volcanoes are really abundant here in America's Northwest. But we also see lots of volcanism happening in Hawaii as well. But not all igneous rocks are forming from lava at the surface. Most of the magma on our planet never reaches the surface. Instead, it's trapped under the crust. So instead, that magma is going to solidify inside of the planet and be known as an intrusive igneous rock. And I remember this, it's intrusive because it's into the planet. And generally, we only see these intrusive igneous rocks once they've been exposed at the surface by all of the rocks above them being eroded away. And we'll talk about this more when we get to sedimentary rocks in a couple videos later today. But we can see these deep igneous rocks that form deep inside of the earth in places like Yosemite National Park in California and Mount Rushmore in South Dakota. But we see that as this lava or magma is cooling down and turning into a solid, that minerals are the first things that start to develop. So as this lava or magma is cooling down and beginning to solidify, we're going to have crystallization occur, where mineral crystals start to solidify. So most of the magma is silicates. It has silicon and oxygen in it, as well as some dissolved gases like water vapor and carbon dioxide, but it's confined by pressure. Think about the carbon dioxide inside of a can of soda. It's under pressure until you open it, just like the dissolved gases are in magma. But inside of that magma, we also have very small, solid mineral crystals that are starting to form. And as that lava or magma cools down more and more, we're going to see that ions, different elements or different atoms, are going to start arranging as they cool, forming that crystalline lattice that we talked about with minerals. And as cooling continues, just more and more ions are going to be added to these small crystals until all of that liquid lava or magma becomes a solid, where we have interlocking mineral crystals, and this is what we call an igneous rock. But how fast that lava or magma cools down is actually really important when it comes to igneous rocks. And this is because the rate that it cools down and turns from a liquid into a solid determines exactly how big those mineral crystals can be inside of the rock. So if we have a slow cooling rate, this means that the lava or magma is going to have a really long time to cool off and turn from a liquid to a solid. So when we have slow cooling, we're going to have fewer crystals of minerals overall, but they're going to be much larger in size. Think of it as like a tree. If we give it enough time, enough years to grow, it's going to become very large. But if we have a tree and we only give it a year or two to grow before we chop it down, it's going to be much smaller. So here, if we see very slow cooling, where it takes a long period of time to cool off, we're going to have big minerals. But on the other end of the spectrum, if we have really fast, rapid cooling, there's not going to be very much time for those minerals to grow. They're going to turn from a liquid into a solid too quickly. So those minerals are going to be much smaller in size. But in some locations, we can have instantaneous cooling. Generally, if we have lava dripping directly into cold water, it's going to instantly turn into a solid. And this is going to create kind of a weird igneous rock because there's not enough times for the atoms to arrange themselves in that crystalline lattice. So these rocks that form instantly have no atomic arrangement and therefore no minerals inside of them. So we just call them volcanic glass. And we'll get into this more in a few slides.